M1 Kinematics Example 10. This is quite a challenging example, and this is the sort of thing that you might get towards the end of an exam paper. We've got a particle moving along the x-axis. The x-axis, as we know, is positive going towards the right. It's got a constant deceleration of 2.5, so we write that as minus 2.5. At time t equals 0, it passes through the origin, so that would be our starting point. And we're moving in the positive x direction with a speed of 15 at that moment in time. What we've got to work out is the time between the instant when the particle first passes through the origin and when it next returns to the origin. Now this is very similar to example 8. It's coming along, decelerating, eventually somewhere it will come instantaneously to rest, and there will be a point where its velocity is 0. At that point, because it's still got a negative acceleration back towards the origin, it will start to move back in this direction and it will pass through the origin again. Now at that point, the displacement S from where we started from is 0. And we did that in example 8. So using that information, we can use the equation S equals ut plus a half AT squared. Substituting in, S is 0, U's 15, T we don't know, half, A is minus 2.5, and then we've got T squared. Okay, so simplifying, we've got 15T minus, now a half times minus 2.5. Well, that is 5 over 2. And if you times that by a half, that's 5 over 4, 1.25. Now you can factorise it like that, but I would probably try and make the numbers into integers. So if we think about what to multiply through by, this is in quarters. So if I multiply through by 4, just to make this look a little bit neater, 4 times 0 is 0. This will be 60t. And then 4 times 1.25 would be 5. And that just makes it look a little bit neater. We can now factorise it, take out the t, and so we've got here either t equals 0 or 60 minus 5t equals 0. And if you rearrange this second one, you get that t equals 12. What that tells us is that the particle moves up to this end and comes back again in 12 seconds. So that's part A. Part B, we've now got to find the total distance travelled during this time. So remember, displacement is how far you are from the starting point. We want the actual distance it travels during that time. So we can't put S equals 0 because S is displacement from the origin. But what we can do is work out how far it's gone when it comes to instantaneous rest. It will then move the same distance back to the origin, so we can just double our answer at that point. So I'm going to look for the point where this particle is instantaneously at rest. It just comes to rest and then turns around. The acceleration throughout the motion is minus 2.5, and we started with a speed of 15. We want to work out the distance to that moment of instantaneous rest. And so I think the equation we're looking for is v squared equals u squared plus 2as. V is 0, u squared, 15 squared is 225. And then we've got 2 multiplied by minus 2.5 times s, which we don't know. Okay, simplifying, 225 minus 2 times 2.5 is 5 times s, and if you rearrange that, we'll have s is 225 over 5, which is 45 metres. Now remember, that's the distance from the starting point to the point of instantaneous rest. It then moves all the way back to the origin. So during the whole motion, it's doing that 45 metres twice. And so in total, it's gone a distance of 90 metres.